Assalamualaikum everyone. My name is Abdul Aziz bin Johari and today I will present my case study on optimizing a home network. So this project focuses on addressing the challenges of a modern household network and proposing solutions for improved performance and reliability. First we go to the introduction. Um, the study analyzes an 815 square foot home with 5 members using 7 smartphones and 5 laptops for streaming, gaming, studying, and browsing. The network relies on a hotlink prepaid plan of 40 ringgit offering 200 gig data at 12 Mbps. However, this setup struggles with Wi-Fi coverage, performance under simultaneous usage, and scalability. Our goal is to propose cost-effective solutions for optimization, scalability, and security enhancement. So next, we're gonna look at the problem with the current network. So the first one is insufficient speed and bandwidth, which is only at 12 Mbps. It cannot handle multiple devices effectively. And the next one is coverage issues. A single router creates dead zones, especially in distant rooms. Next is device congestions. Overloads occur during high bandwidth activities like gaming. And we go to the scalability constraints. The network cannot support additional devices without performance degradations. And the last problem is high latency. An average latency of 29 ms causes delays in streaming, gaming, and video calls. So we go to the next slide. We have our network topology of the current network. So the logical network design represents the current layout of the home network, where a 4G 5G router connects directly to the ISP, distributing wireless connectivity to all devices. This design highlights a core layer, distribution layer, and network layer with no intermediate devices like switches or extenders, resulting in potential bottlenecks and limited scalability, especially when managing simultaneous connections from multiple devices. So the next slide is our physical design or floor plans of the house. So the current router, as you can see here, is placed at the far left corner of the living room, surrounded by walls and furniture. This placement obstructs signal distribution, leading to dead zones in the bedrooms. With 7 smartphones and 5 laptops, the lack of additional access points further reduces performance, resulting in a congested and inefficient network. So here we have a table of the internet working device, which I only use one device, which is the R312 router. The specification is as follows. It supports 4G and 5G up to 300 Mbps. Network, it uses 3G and 4G LTE network and have a one LAN port. Its working distance is up to 20 meters and it provides security including WPA personnel, WPA2 personnel, and WPA2 AES personnel. So as we all know, the role of the router is as the core gateway to the internet. And of course, this router needs upgrade for a better throughput. So we go to the proposed solutions for each of our problem. For the first problem, which is Wi-Fi speed and bandwidth, we have to upgrade the ISP plan to a higher speed fiber option, which is 30 Mbps or higher. And of course, enable the QoS, which is the quality of service, to prioritize critical devices. So the second problem we have, which is coverage issues, which we have to solve by relocating the router to a central elevated position for better coverage. And the next one is device. The next problem is device congestion. So what we have to do here is we have to upgrade to a TP-Link Archer X73 Wi-Fi 6 router for a better bandwidth management. It also offers speeds up to 5400 Mbps. So the next one is scalability, which introducing a scalable mesh Wi-Fi system compatible with Wi-Fi 6 for future device support. And to solve the high latency problem, we have to opt in for a router with advanced features like OFDMA, beamforming to reduce delays and switch to a low latency ISP option. So we go to the next slide. We have the physical design of our suggested network. So here, as we can see, the router which originally located here at the left side of the picture is now centrally placed in the living room for even signal distribution. Mesh Wi-Fi nodes also added to improve coverage in larger areas like bedrooms, and the router also have been upgraded to the TP-Link Archer AX73 router, which offers faster speeds, advanced features for better device handling, and reduced latency. These changes ensure seamless connectivity for 12 devices, accommodating higher traffic loads and future scalability. We have come to a conclusion, which is the current network with a single router placed at the far left of the house struggles to support a modern household needs due to limited speed, high latency, and poor coverage. The proposed solution includes relocating the router to a central position, upgrading to the TP-Link Archer AX73 Wi-Fi 6 router for faster speeds and lower latency, and adding a mesh Wi-Fi system to eliminate dead zones. These upgrades will create a faster, more reliable network with even coverage, improved bandwidth management, and scalability for future demands, all within budget. So that's all from me. Thank you for your attention.